Hi guys, my name is Untitled and today I'll be tutoring you guys on inverse functions, mathematics, grade 12. Let's start. Okay guys, what you need to know about inverse functions is that inverse functions, it's all about switching x and y. Think of the word inverse itself. Inverse basically means opposite of whatever that you're given. So an inverse function, to find an inverse function, you're going to have to switch the x and the y of the original, and it's a reflection. The graph will be reflected in the line y is equals to x. So I'm going to do an example with you guys to start off with, to show you guys exactly what we'll be dealing with. So let's start. Over here I have a quick example. I have the equation of the function. You can see that the function is written with a small f, and we have y is equals to 3x plus 6 as our original function, and our inverse function in red is f to the power negative 1. I don't know what's the mathematical word for this, but it cannot be, I'd say f prime something, but it's not a prime because we deal with primes when we get to, what do you call it, when we get to calculus. So I'm not gonna mislead you guys, I'm just gonna say it like I see it because I'm not a teacher. I'm just doing my best. And remember what I said, inverse functions are all about swapping x and y. Here we have y is equals to 3x plus 6, and here we have x is equals to 3y plus 6. So you can just see that they literally just swapped the x and the y. Fine, here we are given the y-intercept and the x-intercept as negative 2 and 0 and 0 and 6. We now have to find our x-intercept and our y-intercept for the inverse function and plot in our graph. So I'm going to do that with you guys, and let's get on it. I'd show you guys, okay, I'm just going to do it the right way first, and then I'll show you guys how to do it much quicker than having to follow all the steps. First of all, we're gonna see we're gonna have to make y the subject of the formula, because even though it's like this, even though they swapped x and y, x shouldn't be our subject of the formula. You always have to make x the subject of the formula whenever you work with equations. So let's do that. If we have x is equals to 3y plus 6, we're just gonna say x minus 6 when we transpose it, and then we divide both sides by 3, and we're gonna have y is equals to x over 3 minus 2. This is our inverse functions formula. So now that we have to find the x-intercept and the y-intercept, we're gonna let y equals to 0 and let x equals to 0, the usual way that we know it. So instead I'm just gonna put it in here. Let me do this. Now to find the x-intercept, we're gonna say let y over 3 minus 2. We transpose the 2 to the side, it's going to be x over 3. Multiply both sides by 3 to get rid of this 3, and x will be equals to 6. And now we have our x-intercept as 6 and 0. And now we come back to our graph. It's probably going to be somewhere here, but let me use red. So if you're going to have and now to find the y-intercept, we're just going to say let x equals to 0. Let x equals to 0, y is going to be 0 over 3 minus 2, and y is equals to minus 2. And now our y-intercept is minus 2, and what am I saying? Our y-intercept is 0 and minus 2. Coming back to our graph to plot it in, it's going to be somewhere here. Now let us construct our graph. I don't know if it's going to be. It's not drawn to scale, so please excuse me. So yes, remember I didn't show you guys the line where the line y is equals to x. It's going to be here. Over this line, the original will always be, it's a reflection. Actually, the inverse is a reflection over this line. So if you're gonna do a practical on this graph, take a mirror, put it here, you're gonna see that this line is exactly the same as this one if your graph is drawn to scale. So yes, moving on, what I want to show you guys is that looking at these 4 points, here we have, for the original graph, we have original graph and our inverse function. What we have is 0 and 6, and we have minus 2 and 0. Remember, inverse functions are all about swapping x and y. So coming here, all that we had to do was, instead of having to do all the steps, all that we had to do was just swap x and y to get the coordinates of our inverse function. So remember, this is our x and this is our y. So we just swap them. It has to be y and x. Then we're going to say 6 and 0 and 0 and minus 2. Coming back to our graph, we have the exact same coordinates. We have our 0 and 6 and our minus 2 and our 0 and minus 2. These don't change. I'm just trying to make you guys aware that for our inverse function coordinates, we're going to have, basically our first one will be the y of this one. So I hope you guys understand and now have a clear image of what inverse functions are all about. Now moving on, I'm going to explain to you guys what a function is and the type of functions that we have. I'm now going to explain to you what a function is, what a one-to-one function is, a many-to-one function is, and a one-to-many function is. Remember that. First of all, to start off, we have 4 functions. We have the straight line, the parabola, the hyperbola, and the exponential. Those are the functions that we're going to be working with, and all of them are functions. Why? Because I'm going to introduce to you guys a new concept which we call the vertical line test, whereby the vertical line cuts the graph only once, which is why all those four functions that I have mentioned are functions. So let's start. First of all, we're going to define what a function is, and all the others will follow. So a function is, it's not really a function, not what am I saying? It's not a definition, but I'm just going to paraphrase it for you guys. It's defined whereby for each x value there is only one y value. What it means is that each x value will have only one y value. So here we have a one-to-one function whereby each x value has only one y value, and I'm going to demonstrate to you guys that in a very simple way. Let me use a different color. I hope you guys can see because I'm doing this at night, so my ring light is sort of reflected here in the board, and I hope it's just not, please forgive me. X and y. See, each x value has only one y value. Each x value has only one y value. Each x value has only one y value. A many-to-one function is whereby more than one x have the same y value. So I'm going to use 4. So there's like more than one x values having the same y, more than one x value having the same y. And a one-to-many is when one x value has more than, supposed to be has, not have, is more than one y value. So x and y, more than one x value has more than one y value. Okay. I'm now going to show you guys that from the four functions that we have, the straight line, the parabola, the hyperbola, and the exponential, which one falls where. So basically what's going on is that the three of our four functions fall in here, fall under the one-to-one. We have our straight line, our exponential, and our hyperbola, and our exponential. And here we have our parabola falling here. So our straight line falls here, our hyperbola and our exponential, our parabola falls under one-to-one. And our one-to-many is something that we're still gonna learn. Our one-to-many is actually an inverse of this one. It's an inverse of the parabola, because you can see it's just facing another way. It's a parabola facing another way, meaning it's an inverse of this one. But this one, what you guys should know is that the inverse of this function, of all these three functions, the inverse will be a function. It is like that. If you ever if you're gonna do it anyway, what you should always know is that a one-to-one function, its inverse is always gonna be a function. But this one, a many-to-one, the inverse is not a function. Because why? this is not a function. If we're going to do the vertical line test, which is that for each x value there's only one value, and the vertical line should cut a graph once. First of all, let's deal with this one. It says for each x value there is only one y value, and let's see here, it says for, okay, one x value has more than one y value, meaning it's not a function at all. Why? Because it doesn't have the same definition here. And if you're going to do the vertical line test, the vertical line is cutting the graph twice. It's cutting it there and it's cutting it here, putting it again here, cutting it there, cutting it. Can you see? It's a continuous thing. The vertical line is always going to cut the graph twice, meaning this function, this graph is not a function. And this one, if you're going to do the vertical line test on this one, it cuts the graph only once, even though it has like two sides, but it cuts the graph only once. And here, if we're going to test it on the straight line, the vertical line is always going to cut the graph once. Same thing here, because it's two different parts. And here, the exponential one, it's always going to cut it once. Now, I just want you guys to make this note so that you don't ever forget this. The inverse, remember, an inverse is now represented with f to the power minus 1 is a function Now, going back to the one-to-many function, remember this graph is an inverse of this one. Now, if we're going to be asked to draw an inverse of this one, the inverse of this one is going to be the parabola, which means that the inverse is going to be a function. Because if it's going to, remember, we have our line y is equals to x, which is always the same for every graph, always the same, and it is dotted, it's not constructed fully. If we're going to be asked to draw a reflection of this graph, this part over here of the graph is going to be reflected here, and this part of the graph is going to be reflected here. So can you see that the inverse of this one is this one? And if we're going to draw an inverse of this one over here, this part is going to be here, and this part of the graph is going to be here. So an inverse of this one is not a function, and an inverse of this one is a function. So I just want you guys to know that these two actually go hand in hand. They are inverses of each other. And this one is going to be easy. Drawing an inverse of the straight line is just going to be here. An inverse of this one is going to be here and here. And an inverse of this one is just going to be here. So okay, yeah, there's something that I wanted to say. I'm thinking a lot. They're gonna ask you if you're gonna get a many-to-one, an exercise or a question in an exam. They're gonna tell you to restrict this graph so that the inverse is a function. So that's what I'm gonna show you guys next. We have here is the graph of fx, where fx is equals to x squared, and this is our parabola at the original. So our first question is to limit the domain of fx so that the inverse of fx is a function. So I'm gonna break down to you guys this whole concept of limiting your graph so that its inverse is a function, so that you don't get it confused, so that it's always going to be here, like here. Anyway, can we do this? I'm going to use red because I feel like it pops more. This side of the graph, what we know is that, I'm sorry, my graph should be actually at the origin, but it's not, which is going to be confusing. From this point over here, going there, what we know is, okay, the domain works with x and the range works with y. So from this point going there, we know that our graph, the domain would be x is smaller or equals to x to 0. Why? Because remember, at the origin is always 0, or origin is 0. So from this point over here, the graph is either equals to 0 or smaller than 0. Negative, on our number line, this is the negative side. And now this side, from here, from 0 to infinity, x is greater or equals to 0. As you know that this side of our number line is bigger than 0. So fine, start for like each side of the graph, it starts here, literally at the origin. So these are the two inequalities that we're going to use to limit our graphs, as we know that our graph can either be smaller or greater than 0, or what can either be smaller or equals to 0, or x can be greater or equals to 0. So I'm going to show you guys how you're going to draw your graph. Okay, what is going to be the result if your graph is limited to 0. So what I want you guys to understand as well is that what it means is that if we're going to say, because okay, if remember they asked us to limit our graph, right? This is going to be our function still. It's still going to be a parabola, but we're just going to put in x should be greater or equals to 0. But what this means is that this part of the graph from here where it is 0 and smaller, it's not going to be visible in your graph. It's going to be ignored in a way. So therefore we're just going to have, let me do this. We are just going to have this part visible. We're just going to have where x is greater or equals to 0, which is here, because there it is smaller. But if we're going to say that x should be smaller or equals to 0, then what it means is that this part of the graph is going to be ignored, and only this part of the graph remains. Why? Because here we said that this is the equation of our graph, but only where x is smaller or equals to 0, and this side of the graph is only where x is smaller or equals to 0. Fine. Now we're going to draw we're going to have two Cartesian planes, or I'll just see the side just now if I'm going to do one and then the other, but for now we're going to have two Cartesian planes where I'm going to show you what happens, what's the situation when x is greater or equals to 0, and what's the situation when x is smaller or equals to 0. Okay guys, we have our two Cartesian planes, two different situations when x is when x is greater or equals to 0, and when x is smaller or equals to 0, which is here and that part. And our graph is still the equation of our function is still f of x is equals to x squared. our function hasn't changed. It's not an exponential or something new. It's still a parabola. So now what we're gonna do with this graph, we're gonna draw here we're gonna be drawing the inverses of our functions, and then what we're gonna do next is our domain and range and what not. I'll show you guys that later. But for now we're just gonna draw the inverses of our two graphs. So remember, our inverse function is a reflection in the line y is equals to x, which is this line. I forgot to write that. Is a reflection in this line y is equals to x. So what we can already imagine is that if we're going to put a mirror here, this graph is going to go somewhere here. And let's draw that. From this part, remember it's from 0. So it's going to be like that. Just imagine it as a bird. A bird, and here the inverse is going to be a reflection on this line y is equals to x, which is going to start from this point, which is our origin. If you're going to put a mirror here, what you know is this part, this part underneath this line y is equals to x is going to go here over this one. It's going to be just above it, but that one is going to come here. So our graph is going to start from our origin, which is 0, and it's going to go like that. Can you see? So we have a bird and we have a fish. I think you guys can use that to remember. So yes, these are our inverse graphs. It's literally very easy if you understand that if you know that it's just the inverse graph will always be a reflection in the line of y is equals to x. You're not going to struggle too much, and if you just know how to use your two inequalities as limits. And what you guys should know is that, remember what the question said when we started, that we should limit the domain. So we know that this already is our domain, because if our next question is going to be write the domain of your graph, the domain here is going to be x is greater or equals to 0. Why? Because this is literally the only part of the graph that we have whereby x is greater than 0. Domain works with x, and here our domain is going to be this, where x is smaller or equals to 0, and that's what we have here. We don't have the other part, so we cannot say x is the element of real numbers. That would only be possible if we had our entire graph, if our graph was unlimited. Okay, and now moving to the domain and the range. The domain of, okay, what you guys should know, I hope you guys will be able to understand this, because this takes a lot of understanding and focus. What you should know is that the domain of our original function is the range of our inverse function, and the range of our original is the domain of our inverse. So this is all about swapping x and y. Can you see that it keeps on repeating itself? It's all about swapping x and y, and you guys are going to see that just now when we start. But let me do this quick thingy here. So this is actually a sketch of what I've been saying right now. Maybe some of you didn't hear me, but at least you can pause. The domain of our original is the range of our inverse, and the range of our original is the domain of our inverse. which is what you guys are going to see now. Let's start first with the, I'm going to try to use two different colors. The range, the domain of this graph is, yeah, we have it. X is smaller or equals to 0, and our range is obviously going to be, y should be, y is greater than 0. Now this graph is x is smaller or equals to 0, and our range is y is greater or equals to 0. Why? Because our graph starts here, and if our graph starts here, it cannot, we don't have a part of our original graph below 0, so we cannot say y is the element of real numbers. Now what I've said here, I think this is the easiest way of you guys remembering this and understanding this, because if you're gonna try to derive the domain and the range from this graph, you must probably gonna get confused, most likely actually. But we can do it that way. The domain of our graph is gonna be x is greater y, x is greater or equals to 0 y, because our graph is starting from 0 to infinity, so we can say x is greater or equals to 0, and the range we're gonna say whereby x is smaller or equals to 0, because we don't have a part of this graph above 0 or greater than 0, so we're gonna say y is smaller or equals to 0. What I want you guys to see here, remember what I said. Can you see that these two equations are exactly the same? The only difference is that they swapped x and y. Here's what I said. The domain of the original is the range of our inverse, which is exactly that. It's just that they swapped x and y. We have our domain as x is smaller or equals to 0, and our range is y is smaller or equals to 0. Can you see what they did? They just swapped x and y. That's all. And now here we have our range as y is greater or equals to 0, and here we have our domain as x is greater or equals to 0. All they did is swap x and y, and it's all here. If you know this, you will be able to double check if you're going to use that. I'm going to do the other part of our graph where x is greater or equals to 0. So we already have our inverse graph and our original graph. Our domain for this graph is already here, is x is greater or equals to 0, and our range is basically the same as that one. y is greater or equals to 0, and our domain for this one is x should be greater or equals to 0, and the range we have, because we don't have a part here of this graph, it should be above. We don't have a part whereby the graph runs like here, so we can only say that y is greater or equals to 0 because it goes above the line to infinity. And this one is actually very easy because these two are basically the same. They're in the same quad, so there isn't much of a difference. Unlike what we're going to do right now is to find the equation of our inverse function, which is very easy, and we're actually wrapping up this whole lesson. So let's do it. We're gonna swap x and y. We're gonna have x is equals to y squared, and now we have to we have to make y the subject of the formula. So we're gonna say to get rid of that, let's put it here. Plus or minus. Remember, we're going to use this plus or minus because we had two situations whereby we limited our domain. X should be greater or smaller than 0. So we're going to have our y as and this is going to be our answer, whereby we're still going to put our limit greater than 0, or we can have our answer as y is equals to minus. This is because that remember, okay guys, I'm gonna explain these two limits of our domain. Here our limit is for a positive square root, x is going to be greater than 0. Even for a negative one, x is going to be greater than 0. But because the range of this one, x was greater than 0, remember what we had was, we had something like, it was here, our inverse function was like this. So the range of this inverse function, x was greater than 0. But for this one, we had something like this. Our graph was somewhere here, and this meant that y was smaller than 0, so it gave us a negative for the x for the square root. So you have to kind of understand this part, but I can't explain it. I'll probably explain it better the next lesson when we do more work based on this. So that's all that we had to do, and that's all that you guys had to understand. If you guys enjoyed this lesson, please share it with your friends, and please send in questions whether you have problems or you're having complications, so that we can ace this for this lockdown.